My name is Paul MacKay. I'm a software engineer architect at Ancestry, and I'm here to discuss some of the attributes or experiences that we've had as we've made our journey to Kubernetes in the last year or so. So hopefully you're in the right place at the right time. And hopefully there's some things that you can gather, whether you are going through the transition or have gone through the transition to Kubernetes. Hopefully there's some insights that you can glean. I like to think about, when I talk about a kind of a journey, I always like to figure out kind of where you've come from, some of the things that you've learned, and then kind of talk about where you are in the journey. And so I'm going to take those three type of perspectives. So first of all, let me get a clicker here. Who's heard of Ancestry before? Oh, wonderful. Great. Hopefully it's been a good experience for you. As you know, we've been around a bit. Our business is centered around science and technology that really has a human mission. And that mission is really to bring people together, to have them understand their backgrounds, their histories, anything that's related to them, to help them understand themselves as well as those around them. And we started a while back with family history as far as a lot of the documents and searching capabilities. And in the last few years, we've also embarked upon DNA and the science of genomics to also help connect people together. One of the things that we found is that as people learn more and more about themselves, they find that we're more connected than not. And so that's a nice thing about Ancestry, too, is connecting people. Data drives our business. It's all about data. We have billions and billions of historical records that we have created and categorized over the years. We have millions and millions of family trees and billions of profiles. And again, as it says, millions and millions of historical photos, documents, and histories. And so you can imagine this kind of accumulates over the years, and we have petabytes of data. So we truly are a data-driven company. And as our DNA efforts have grown, we now have one of the largest consumer genomic databases, over 2.5 million, that again is useful in helping understand even more connections with people. So that's kind of where we come from as far as Ancestry as a company. Now, I want to talk about some of the technologies that we have used in the past. And maybe they're common to what you have in your own organizations. We come from a Windows background, a Microsoft shop. Kind of just very quickly, our history started back in 1983. We were a publishing company. We were publishing magazines and information about genealogy and family history. Back in 1996 is when you look at Ancestry.com today, that the roots of that really started in 96, when we introduced some of the first online family history resources available. And at that time, we were kind of an enterprise Windows shop, so the majority of our services are written in .NET and using SQL Server, IIS, and just a very traditional Microsoft shop. And it served us well. We, through the time of several years, also have accumulated some services in Java, Node.js, Python, running on Linux, but still the majority of the technology has been in Windows, Microsoft stuff. We have our own private data center. We have thousands and thousands upon thousands of servers. We run our services on top of VMs, and so there are literally thousands of VMs running on those thousands of servers. And we serve over 75 million searches a day for family history information. So it's been a great site, still is a great site. The technology has been really great for us. But in the last little while, we've realized that we do need to transition to other open source Linux-friendly technologies. And so that's kind of why we're here today talking about Kubernetes and our transformation in certain areas regarding that. I'd like to also talk about our development process, kind of give you some framework of how developers have done things in the past. Very traditional CI/CD. We've used various technologies, the puppets, the chefs. We've used Go, the cruise control from ThoughtWorks, and Jenkins, you name it, as far as traditional deployment methodologies. And as I mentioned before, our services have resided on VMs. And it has been kind of the convention that we would have one service per VM, and then we would just scale up VMs as we needed to with load and such. But as you can imagine, and maybe how you experience it yourselves, deploying on VMs, orchestrating all that takes a lot of time. And so our deployment time for the Windows stacks and even the Linux stacks can take between 20 and 50 minutes as the deployment process goes from one stage to another. And so the reaction time for deployment is quite long for developers. And so that's one of the kind of the reasons why we're going to talk about Kubernetes today. So that's kind of where we've come from. And now I want to talk about some of the things that we've learned along the way here as we've made our journey to Kubernetes. So first of all, change is hard. How many engineers are out here? Yeah, okay. So we don't like change. I mean, we say we do, we adopt new stuff, but we really don't like change. We're very stuck on a lot of things that we know already how to do, right? We're comfortable with ways of doing things, and in fact, in many ways, we think that the current way, or considered the old way, is a lot faster. One, because we know about it, and two, we're just comfortable with it. And it's very hard for engineers, for us to really see an advantage of change unless we can really see a very good, very significant incremental benefit for that change. And the notion of change in itself is it has real cost. The notion of just changing for change's sake is great, but for a business, you just can't do that. And so change really takes away from the developing of new features, which bring in money, right? And also change elongates the schedules of developing those new features. So anything that we do as far as change, there is a cost to it. Nothing is free. And so when we talk about adopting new technologies, it requires kind of a new paradigm or a new pattern to follow. And this is kind of what we have developed, and it's very common. But where we try to understand how to develop new technologies is the first and foremost is understand the current technologies and processes. It's nothing new. You can't change unless you know what you're changing from. And so as we've just talked about our technologies in Windows, our deployment methodologies with VMs, it is incumbent upon us, if we want change, to make sure that we understand the current technologies, understand how the developers are doing things and such. The next is kind of an interesting approach, but you need a patron. You need somebody that can champion from the upper echelon down to help change occur. You need somebody to give you air coverage and give you the time and the resources to actually investigate and make these changes. We all think that grassroots is where it all happens, and it's true. You do need to have change come from the grassroots. But if we don't have a patron or somebody that's championed that can help with initiatives to actually drive the organization forward, and then having the grassroots and the upper initiatives, change is not successful. And so we find that has been a very important part of our change as well. The other is you have to own something to be real. If you want to change something, if you want something to be different, it has to be something that you will do yourself. If we're not willing to be a part of that change process, and we're always just trying to dictate to people, it's just not going to happen. Or if it does happen, there's a lot of resentment, and then there's also some frustration. So the thing is always find out how you can be real by owning and being part of that change. And then the next thing is to create a partnership. That if you're going to make changes, make sure there's a partnership with pilot teams and others, so that if they're successful, you're successful. If they're not successful, you're not successful. And that's a very key part in adopting new technologies. And we've tried to use this pattern as we've adopted new technologies within Ancestry. So let me just talk about kind of how we started in this transition from a Windows VM world into containerization and then to Kubernetes. About 3 years ago, in fact, it was 3 years ago this week, I attended KubeCon, which is a great conference. I'm not sure, has anyone gone to KubeCon before? Okay. KubeCon's a great conference for architects and for others that just is a very nice way of just gathering together and learning new technologies and not too much vendor stuff, which is very nice. 3 years ago, I attended KubeCon, and Docker kind of was the little buzz. You know, sometimes you go into conferences and you hear little buzzes as to what's kind of coming out. It was in beta, and it turned out to be something that a lot of people were talking about at the time. I came home from the conference, and in a previous life, I had worked in software virtualization. I have a large background in Unix and Linux, and so containerization or the concepts therein were familiar to me and made sense. So I began experimenting with Docker, tried to incorporate some tools and some little services just in my own way, and then began to, as Docker Compose came out, to kind of assemble little things, and Compose is great for that, for single boxes. And then we also got some individuals on the team that were excited as well, and we created a Docker agent, which had a little REST endpoint that we could put on a box, and then we could deploy containers, and we could do various orchestration. And then we actually then started demonstrating to people, to developers, to management, and say, hey, this is a lot easier way to deploy and to scale up the services. And so it was kind of this grassroots type thing. And we could then really prove to people, very demonstrably, how much faster this type of methodology is compared to the current, Go, Chef, pipeline type methodologies that we're using. And also, kind of as a byproduct, is we were able to show a greater density of putting services on our current computing resources, which is, again, is a plus when it comes from a business standpoint. And then we have to own something to be real. We had our own services that make up some of the aspects of the site, and so we started deploying those as well in Docker. Now, what's interesting about all this is some of the early discoveries, okay? So this is great, new technology, Paul's coming in, Docker is wonderful, let's change the world. But there's always something that you learn, right? One is we found out that really the normal Linux distros are just way too big, right? They're just way too big to do the kind of things that we were wanting to do. They're not specifically built for Docker. It's kind of an add-on to them. And so it became difficult as we started to use the corporate blessed image, for Linux to then put Docker on and have it work well. And as I mentioned, it's just way too large of a footprint. You start not utilizing the resources that you have in a good way with memory and all the other things. Excuse me. And the notion for security and this operations is that there are just way too many packages to keep up to date to worry about security issues. And the other thing is that Docker really needs later kernel versions. They really almost need that bleeding edge of kernel versions with the newer capabilities and such to perform well as to have all the security and other aspects that make it real. The other thing that we found out, given it's not a no-brainer, but we have had a lot of Windows developers, right? And so we found early on that yes, we were so excited, those that knew about Linux and containerization in general, that all of a sudden these Windows people were kind of like, oh, what is VI? What do you mean command line? What is that? What do you have to do that for? And so we ran into that notion of a cultural change, There's cultural change, not just technical, but cultural change in having people learn and adopt Linux-type concepts. And then we found out, I know it's kind of surprising, orchestration is hard to do right. You know, we're pretty good engineers. We thought we could do some good stuff, and we actually demonstrate some good things. But the notion of really in a production quality environment, orchestration is hard to do well. So early on, I said, okay, we need a better Linux. We need something that's built for Docker, and so therefore CoreOS came into play. I evaluated several of them, and CoreOS turned out to be what I thought was something that we should focus on. Again, you can talk to the CoreOS people. You probably, in fact, who uses CoreOS here? Okay, wonderful. It's built for Docker. It's a first-class citizen, you know, running containers, I should say, in CoreOS. The updates are holistic. I don't know if anyone went to the presentation last night with Brandon Phelps from CoreOS, where he talked about the dirty cow security issue, right? What's nice about CoreOS is this notion of holistic change, meaning you can update, push the change to the boxes, and then just do a quick reboot. And so the nice thing is that you can push them to the machines, but I think what's even nicer is that if there's a problem, you can quickly roll back, and it's a holistic change versus this Debian, you know, RPM, you know, menagerie of making sure you've got the right combo of dependencies and all that type of thing. So very, very nice as far as in the operations and management. And coming from the Unix background, less is more. It really is. And so as you have fewer packages, there is a statistical reality that you'll have fewer vulnerabilities. And so that's what we found as well. So the operations of the Linux underneath is a lot easier to manage. And what's interesting about CoreOS is it's really bare bones. When I say less is more, it is less on CoreOS, which is great because it's built to run containers. And so because of that, we've found it's very infrequent that we have to get on the boxes. Because if we do and we want to do anything, we've got to bring a container to run it on. So in that essence, it's also very easy to manage. Well, so we've got our Linux. We realized orchestration is hard. Then I started looking at some orchestration opportunities that are out there, and I thought, hey, Kubernetes. This is something that's kind of cool. And so started creating a sandbox cluster, a cluster for our group that could be playing with, understanding, getting familiarity with the concepts of Kubernetes. And so then we created that for our own type of deployments. And then we were able to, after we demonstrated to management that this was a good idea, what containerization and orchestration through Kubernetes, we've got this air cover to say, okay, you've got some time, Paul, and your team. Get some teams to be part of a pilot program to see if they can then utilize this technology. Now, one thing I can say about this is when you do create these pilot teams, or when we gather these pilot teams, make sure you find people that are very vocal, that have problems, hard problems to solve. Don't go the easy route. Find things that are hard to do, small enough that you can cope with them, but then find people that will really give you honest and deliberate feedback. And so that's one thing that we were able to do. We had daily stand-ups with them. We became part of their team as well. And so we started to understand their processes, understand what they do, their needs, the problems that they currently have. And that was a good thing to do. The other thing is that, like the Windows training for Linux, Windows developers for Linux training, we then had to create our own Docker, containerization, and Kubernetes training program in which we would educate, help other people understand more and more about it. In the same vein, of course, we came up with some templates and some scripts along the way that became beneficial to us and to these various teams. So now, where are we on this journey? Okay, we've talked about kind of where we came from, Ancestry, kind of the things that we've learned along the way, and now let's talk about where we are in the journey. Because the journey is still going on. I mean, it's not something that we've finished. Okay, we're still in the process. So where we are today is we've been able to develop certain standards and conventions that we feel that work for us. And so where we are today is we develop these standards. And one of these that's, I don't know if it's that much different from other companies, but we've concluded for us at least that there should be a correspondence between a namespace and a service. There's a one-to-one correspondence. And so I know, how many use that pattern as well? Does anyone use that as well? Kind of? So, you know, you can do it various ways, but we find that the namespace equals a service equals a namespace helps us partition secrets, config maps, tokens, authorization at a very service level. And the namespace has that kind of boundaries. So we have one namespace per service. And we kind of came up with a convention, again, the naming convention. How many love naming discussions, right? You know, what do we call this, right? I can't tell you how many naming convention discussions I've had over the last couple of years. But we finally said, okay, let's find the lowest common denominator, and that is DNS, right? DNS is always the lowest common denominator as far as what characters you can have in the conventions. So we've come up with this convention internally that we would have a functional or a group name, dash, and then the service. So it's just very rateable. And that is used in logging. That's used in, of course, the namespace itself. It's used just across the board. So there's just a very nice correlation between the namespace service and all of its attributes. We've also, as a convention, really concluded for us that one container per pod. Now, excuse me, you know, we all know we can put as many containers as we want in a pod. But it all comes down to what do you want to deploy? What's changing a lot? And we find that for most of our services, they can fit in a container, therefore it should fit in a pod, and so there's a one-to-one. And again, how many do that type of a convention as well? Similar type thing, okay. And so also what we've done where we are today is we've started out with very broad privileges. Okay? Our developers can deploy to dev and stage and even into prod, all the way. Okay? So we've allowed that to be very broad right now. And we've narrowed it as we've needed. And where we've narrowed it, as we've done currently, is that we make sure that the operations, the security team, owns the certs, the username and passwords, all that into production. So they're the ones that push into there. But developers can scale up, can scale down, they can deploy, they can do whatever they need to, even in the production environments. Now, will that change? I don't know. As an engineer, hope not. But I think the key is freedom and responsibility. It's kind of a Netflix mantra that we've also liked to adopt. Give freedom, but then also make sure people are responsible. So we've continued to do that. Another thing that we've decided that works really well for us right now is the notion of separate clusters. We have a cluster for dev, we have a cluster for stage, and we have a cluster for production. And for us, it's a very nice way of making sure that we're controlling the environment, we know what's really in there, and we can also then give privileges, the ACLs that are needed for those environments. And so in our production environment and how we bring things together, we found that we needed our own private registry. We started originally with just bringing the traditional Docker registry down and deploying it, managing it ourselves. And then over time, we realized that we don't want to really be in the Docker registry business, right? And so we worked with the Tectonics individuals, and we use Quay Enterprise on-prem, which really is a nice product, and it gives us a lot of functionality to organize teams and ACLs within there, robot tokens so that we can do pushing in and out with our Jenkins boxes and such. As far as monitoring, we adopted Prometheus over a year ago. And when I say monitoring, I'm talking about the cluster, the attributes of the cluster itself. We use other mechanisms for application monitoring and metrics. But for the cluster and associated attributes, we use Prometheus and have found that to be very, very, very good as far as its capabilities as well as its effectiveness in helping us see what's going on with the cluster. Now, please. Workloads as well, but what I want to say is the question is, do we do workload monitoring with Prometheus? So individual teams and their services have another mechanism where they're doing application metrics and monitoring, but we use it and make it available to everybody to understand how the cluster is performing, and also we do provide for every namespace the current CPU, memory, bytes in, those type of things as a rudimentary measurement of where things are in the cluster. Now logging, oh please.
About the one container per pod,
Uh-huh.
did you feel that you need somewhere to have a sidecar container for like logging?
Okay. Yeah, the question is this notion of a container per pod. Did we have a need ever to have a sidecar for logging and such? Well, thank you. I'm talking about logging right now. We really have tried not to do sidecars. The reason why is in looking at them, one, you're always making sure that they're in sync with everything, that they're working together. What we did with logging is we have created a custom-wide, cluster-wide logging forwarder. We actually use as a starting point the Glider Labs log spout project. And we have it as a single log forwarder for the cluster. We have our developers and the services all write everything out to standard out. So they're no longer files that we use, it's all standard out. And so our log forwarder then reads and hooks into the Docker engine to the actual logging stream. And so we then grab that automatically, and then we actually forward it off to a Kafka cluster that gets consumed into an Elk cluster as well. Logging is a little bit interesting at Ancestry, and maybe you have a similar need or concept. We have forensic type logs, we have business events or type logs. And so this logger also is able to divide those up and know where they need to go. So the business analytics team can utilize the business events, and then developers can use the forensics. What were the challenges or the not having a sidecar? Well, so in this case, it's a log forwarder for the whole cluster. Okay, pods and the service developers, they don't know anything about logging. They don't have to attach in their deployment a sidecar or anything of that sort. This container that we have, the log forwarder, is on every node in the cluster, and written in Go, of course, and it performs extremely well. And all the developers have to do is write their logs to standard out, and that's all they have to do. And they don't have to manage anything else. So for developers and for the environment, this has proven out to be a good thing to do. And with the FluentD and some other things that are coming out, we will track that progress to see if it'll meet our needs. But as I mentioned, we do have some kind of custom things that we do with our business and forensic logs. We also created a namespace portal. So what we have today is a developer can go in, they can log in using their LD, excuse me, their AD or LDAP credentials. They can create a namespace, they can add members to it. And what this does is, because we have all these separate clusters, a dev, stage, and prod, this then actually creates the namespace across all of these clusters and also creates tokens for each developer as well as a robot token that then the CI/CD mechanisms can use. And so this is a way of facilitating the creation and the management of namespaces. And then we have an authorization webhook that Nathan created and keeps on maintaining that then does this notion of who has rights to this namespace and does that check as on the fly when events come in. We also have currently in place resource quotas. Soft in the sense that if a team needs to bump them up, we do it. But what we found, and maybe it's not the case in your organizations, but what we found is that unless we put a quota for CPU and memory, the developers really don't know, for most cases, what their CPU and memory needs are. They've been on VMs, they've been on their own hosts, they've had the whole environment, and so they didn't know if they were swapping or a little bit of this, or if there's a memory, then that would reboot after a while, you know. And so the key is, this kind of is a forcing function to help people come into the environment and say, wait a second, do you really need all that memory for your Java? Do you really need, you know, this amount of CPU? And if they do, then we bump them up. Question?
Are you talking about quotas in both directions, both the minimum and the maximum?
We don't do the minimum per se, but definitely the maximum. We do it at the, of course, at the namespace level. And so this has been a forcing function that's been actually quite good. We've actually found bugs, we've found things that we would not have found unless we've had these quotas. And as I say, if they really need the resources, we just then bump it up, okay? Just as a side note, and I need to talk to the Kubernetes, and actually I think it's a Docker issue. If you are using Java and you are needing computational, you know, really tight, high computation, don't put anything in there for CPU restrictions. It turns out that your performance will go way down. It's very interesting, but our machine learning guys discovered that, and so for them, we don't put a CPU, even if it's a really high one, you just don't put any CPU limit in there. I think the Docker engine then does some nicing and with CPU, and Java just has some interesting things with it. We also created a quick start tool. So it's called Barbosa, kind of the, you know, Kubernetes ship type of theme. And it's really just a quick start tool. It's just to help people to bootstrap, especially when you come from our environment where a lot of people are coming from Windows and such. Getting into VI or Emacs is kind of, you know, problematic. And so we've created a tool that allows them to actually deploy their systems very readily. And what's nice too is it works across all of our various clusters, so they don't have to worry about you know, managing all of that. And it also helps us that we can provide some best practices and conventions to the environment. But I think the key here too is any tool that you create in front of a developer or an engineer has to be transparent. One of the big things that was a problem in current environments is that this deployment thing was kind of throwing it over the fence, right? You just kind of throw it over and let the DevOps kind of get it deployed. And when things happened, it was kind of like very opaque. I don't know what's going on. You had to get a DevOps person. We've tried to make sure we don't get into that world, okay? That we do have a tool, but it's very transparent. You can do a dry run that spews out all the resource YAML files you want, and you can do everything you want with kube control. So whatever tools you have, make it as an option, not as the blocking as to go through. Please. The tool actually does certain things. So for instance, we just have a very small YAML file that is very similar to all the resources that you would imagine. But it does, it does all the service creations, ensures that the node ports are the same across clusters, the high port, it deals with the secrets, it deals with certain annotations. If you're in certain cloud providers, it actually puts the annotations so like the load balancers are created properly. What are some other things, Nathan? Just a lot of those kind of conventions just to help facilitate that type of a thing. And then we've also kind of created some scripts, just very rudimentary. And the reason why I bring this up is because managing secrets and certs is kind of something that people don't think about right up front. But what we've been able to do is we've utilized annotations and labels within our secrets so that we can do versioning of the secrets. So it's very nice for operations and security folks to be able to go across all namespaces and look for this tag or this label of a cert. So if they need to have a reissue of a cert or whatever, we do it via various labels and versioning. So we find that to be a good best practice. We also have created a set of scripts for backing up the cluster and restoring it. So we really can bring up a cluster in just a very short period of time, and we can actually then rehydrate whatever was running in this cluster into this one. And we are constantly backing that up every, I can't remember, is it every hour or every day, or I think it's every hour. And so it has all the secrets, it has everything in it. It's kind of our backup of etcd, but in a very specific Kubernetes way. And then we also have these scripts that we've used to create our environments. And we're tracking very hard, very closely the efforts like the kubeadmin, the kube-AWS, and Kite, and Kops. We're really excited about those so that we don't have to own our own. But there were some specific things that they still don't do or have not done in the past that we've had to create our own for both on-prem and any cloud type of clusters. So our journey so far. Multiple clusters. We have dev, stage, prod. We have a SOX PCI cluster. We have a production support cluster for backend, non-critical but business-related workloads. We have clusters all over the place, all right? We have hundreds and hundreds of namespaces with hundreds and hundreds of pods running in them. We have live production. We've been in live for about almost a year now. And what's interesting is that we now have things that are now being developed for that environment, meaning that that's where they first deployed. We just launched a We're Related app, and all the back end is through Kubernetes. And so now we don't have just the early adopters, we have mainstream development actually going into utilizing Kubernetes. And people find that it really truly is the easiest path to deploy. Please. How do we keep track of the namespaces across the clusters? Meaning, so let's see if, oh, I see what you're saying. Okay, so that's why we have that namespace portal, is that then those that are for the SOX or the PCI cluster have only rights or tokens to go into there. Most everybody has it all the way across the various ones. But where there needs to be governance or auditing type things, that's how we can constrain that. So at the end of this, I can say that we found that Kubernetes really has an incredible amount of power. Now, as a programmer, developer, for those who are out there, we always love this REPL environment, right? This read, evaluate, print, and loop. You know, we love this kind of feedback to understand or to play with in languages. And I would contend that we now have a CETL, meaning Kubernetes now gives us that compile, deploy, execute loop that is extremely fast. It's extremely capable now to deploy complex services, microservices, in a very much of an iterative approach. We're down to seconds, if not minutes, for deployment now, rather than that 10 to 50 to an hour type deployment. And that's it. Any other questions? Let's go over here, please.
So have you guys come across any downsides to your namespace strategy, like managing so many namespaces?
So have we discovered any downsides to the managing of so many namespaces? We have not. It seems to work out well. For instance, that We're Related app on the back end, I think, is made up of 20-ish services, namespaces. And again, it's kind of a nice division as they do microservices and other things. So again, with the namespace portal and some other things internally, it seems to work out pretty well. Please.
Could you expand on what advantages you gained and what disadvantages you mitigated with the one container, one pod?
So what advantages that we have seen or whatever with this notion or convention of one container per pod? I think for us, the issue is just basically what needs to be updated. What needs to really be deployed? What is a version of something? If you start packing on a whole bunch of stuff and you have like something that needs to be updated here, either because of a security vulnerability or something else, it gets cumbersome that you're having to do kind of this. It's kind of like the Incredibles, with the guy with the big old blob of stuff that's finally weighs them down. We just kind of feel like multiple containers and pods kind of does that at times. Please.
So you said you were a data-driven company. What are you guys using for your persistent storage? What are you using for your persistent storage?
Oh, okay, so she asked, we are a data-driven company, so therefore what do we use for our data persistence? Well, I didn't really mention that. And so actually what we started on at first is said those that come in don't have needs for persistent storage. So meaning that we do not use persistent volumes. They would use databases, offline storage mechanisms outside of the cluster. And again, for us, it was easier to manage that in the past. We started out with 1.0. We're now on 1.4, soon 1.45. And so really the volume management, the security of that has started to come in fruition of being where it needs to be. But for right now, we just said, no, use block storage or object store off the cluster. At least that's what we've done. Please.
You mentioned that your VM strategy that you had previous to Kubernetes was really slow. It took like 20 minutes to 50 minutes for you to do deployment. Could you explain why that's so long? That seems really long to me.
So the question is in our previous, and we still have both environments, right, where we have Windows and others that are being deployed into VMs. Why is it so slow, or why was it so slow, meaning 20, 50 minutes? There are various reasons why that's the case. A lot of it was to actually prove the environment before we put the stuff on every time, updates, just convention checking, all those type of things were it just takes time. And then just the notion of bringing them up, the VMs on our Hyper-V and VMware type infrastructures just take time, especially when we're scaling. So it's mainly just physics of how long it takes to do things, to distribute things. That's really what the issue is. And I think I'm way over, and so we need to cut off. If you have any other questions, I'll just come on the back and then we can answer them there. But thank you for being here.